So I'm Danny Swan, and I introduced myself to you guys earlier, but yeah, basically I'm now the Managing Director of Radio Parts, and yeah, it's been great, great couple of months stepping up and having the support of not only Ben, but reps and the guys, the whole team at Radio Parts. I wouldn't take on such a responsibility if I didn't feel the support and the ability of the guys behind me. So it's a great company and we want to continue that. So to that end, yeah, we've been pretty busy couple of months. We've been finalising our catalogue, we've been organising exhibitions and conferences that are going to be coming up in the year ahead. So we really want to sort of kick some goals this year. And yeah, so thanks. This is exciting. This is a really important part of the business too, that we're just going to keep investing and training and building up. We call it the knowledge base, but yeah, it's a term they throw around a bit loosely these days, but I think it's really important. And Ben's going to be a backbone of that, getting behind online webinars.
Yeah, something like that.
Is that something?
Webinar.
I feel like I'm saying it in a French accent.
Webinar is when you look really debonair on camera, which is
a bit of a
me.
mixture of that. So yeah, no, really important, and I really appreciate you guys coming and showing interest, and it's just the enthusiastic customers that we really enjoy dealing with day to day. So thank you, and I'll leave it to Ben.
Cool. Thanks, Danny. That's lovely stuff. For those of you who haven't met me officially before, which I think is most of you now, my name is Ben Marshall. I am our resident geek and product expert, which hopefully means that I know a little bit about a lot of things, and probably not everything I need to know about everything, but I'm working on it. As Danny said, training is a very important part for us, and these information sessions, some will be in incredible depth, other ones will be just skimming across the surface because there is so much more depth than we can possibly cover. And this is one of those. There is so much in terms of testing tools that we work with and use that I'm going to have to be necessarily brief on some things, but if there's something that you're missing or I've gone over something too quickly, let me know. I've also got giveaways, so pay particular attention. There'll be some facts in there that I want you to be able to recite at the end to get some free stuff out of us, which is always nice. To start with though, I really want to give you an idea of what we're talking about with testing gear by starting with some seriously ancient testing gear, in our terms at least. That's a nice analog multimeter from 1968. Beautiful analog dial. It's got the little mirror at the back of it. For anybody who's never used one of these analog meters, the mirror serves an important purpose. If you're measuring from the needle, you have to look directly at the needle, and when the needle's shadow or the reflection of it disappears, you're right on it and you're measuring exactly what you need to measure. That's a parallax measuring effect. You don't obviously need it with a digital multimeter, but when using an analog one, that's one of the things. Big deal with this, I guess, in the modern sense is if you've got a varying signal, an analog multimeter like this, the needle will actually move and you'll see it moving up and down and all over the place as well. Whereas a digital multimeter, if it's not responding fast enough, won't actually show you those same variations. It might not measure at the peak or see where something's going to. So imagine an analog meter like a metronome for a piano. It goes up and down and up and down. And if you're watching it carefully, you can see that I'm getting a spike of 10 volts every 5 seconds or so. And then try to use that to analyze the rest of the circuit. Still, beautiful piece of equipment. I love it. This is actually mine. I bought this one off a lovely guy who actually supplied me another one too. This is a 1984 digital multimeter. It's a very early one. And single line, Japanese made and constructed. Still got a lot of recognizable stuff from today. You've got voltage measurement, you've got resistance, continuity, amperage and so on, AC, DC, multiple ports. It's even got an auto and manual mode on this meter. This is from 1984. It's almost as old as I am. So great little meters. I enjoy having a bit of history for it, although I've got a bit of cleanup and look, I even found the internal circuitry and workings for the old analog one there. So if I've got anything wrong with it, I can go back and fix the thing. But what I loved too is if you have a look across, this is so there's my digital meter, the AD901 that's there, and it's from a company called Emona Instruments. And Danny with long history with the company might know Emona too. They were from New South Wales, so from George Street in the centre of Sydney. But if you have a look over at their distributors, down here, wide range of digital multimeters on the East Coast and represented by Radio Parts further west. They handle Akagawa, Escort and M-Tech brands. So there's a chance at least that this meter was sold by Radio Parts back in the 80s at some stage. So yeah, it's nice to see a bit of history in it, and maybe a meter that we even sold here when I was 3 years old. So moving across from that to something a little bit more modern, let's look at our modern testers. So Radio Parts carries a huge range of testers, everything from electrical testers through to HVAC testers to everything for humidity, sound, light, HDMI, audio, speakers, and so on and so on. A large part of what I'm going to cover today is the electrical testing side of things, because there are more variations, more misunderstandings, and just knowing the nitty-gritty about which multimeter to choose and which one's the right for you is an important thing. I'm going to go through a few bits and pieces of some of the other ones as we go. Obviously, if you want more detail, let me know. All right, let's start with electricity testers. Within this, there are many different things that you might want to measure depending on who you are and what your application is. These are some of the current ones. There's current generation analog multimeters that we still sell. They still work and they're still lovely things. There are specific testers, there's loggers, there's all sorts of other things like that for it. So part of choosing the right multimeter is knowing what you're testing and what your application is. So I've kind of broken it down into sort of 4 main areas that I consider a multimeter going for. A hobbyist or home user might be testing the voltage out of a battery. They might be checking fuse, if it's continuous or not, or if it's broken. Accuracy, who really cares? You know, if it's 12 volts versus 12.1 versus 11.9, that's close enough for what we're trying to do. An electrician, they come in so many different varieties, from process electricians to industrial electricians to high voltage electricians down to domestic and everything else like that as well. Such a wide range. They have different meters that they use as well. CAT ratings are the most important thing for a lot of them about how they're doing it. Then there's insulation resistance testers, whether they're working on live circuits or not. Logging what's going on with power. They don't care what a capacitor or a little part is on a circuit. In most cases, process guys and instrumentation might, but majority of them don't want to know about capacitance, don't want to know about diodes, don't want to know even about most resistances as well. They just want to make sure the voltage gets where it needs to go. An automotive electrician or an automotive engineer might deal with higher current ratings than the domestic guys do. They'll deal with duty cycles because they're dealing with motors. And electric motors, the way that they speed up and speed down is about how they're powered or not as it goes through. Temperature measurement's great for automotive guys as well. Understand where the cooling is going through an engine, parts are running hot or anything else. Thermal's bloody important. And they don't care what a transient response to something is, because most of theirs are big responses. When a transient comes through, it kills things or it doesn't kill things, and that's what they're looking for. Whereas a tinkerer or lab tech, so if you're building circuits based on microcontrollers, if you're looking at Arduinos, maybe even a Raspberry Pi or so on, and you're trying to understand what's actually happening on the circuit, you're looking for nice big pretty displays or computers to show you exactly what's happening with the signal. You're looking at those tiny little transient responses, because that could be the difference between something working and not working. A clamp meter they couldn't care less about, because they're dealing with individual little parts on a circuit, and a big clamp's not going to do the job. So, key features for a multimeter. Your AC/DC voltage ranges and current capabilities. And we're talking about CAT ratings that I'll get into in a little bit. Within a range of multimeters, even at the same price, there'll be different voltage ranges, different current ranges that they're capable of doing. Pick and choose based on the type of jobs that you're doing. There is no one size fits all. Manual ranging, or auto detect. So manual ranging is, say, a meter like this one. If I'm looking at 12 volts DC, I put it into the 20 volt range and I measure my 12 volts. I need to understand what I'm actually measuring so that I don't blow out a meter or do something silly. But I choose the range and then I can work within that range to make it make sense. If I'm doing a lot of work on, say, a 12 volt circuit, that's really easy to deal with because I put it in the 20 volt range and then I just look at my variations and I'm only ever really dealing with that sort of range and working with it. An auto ranging meter means I can plug it into the 5 volt set and it'll choose the appropriate range. 12 volt set, 20 volts, 30 volts, and it'll just keep picking where I need it to be. Plug it into the wall and it'll go up to 240 volts and do with that all automatically in the background. The problem with that is auto ranging takes a little bit of time to go from where it was to where it needs to be next. So if you're only dealing with a circuit that's in a certain voltage range, your auto ranging might take more time than you've got to see what's going on, and it might be a pain in the neck. So there are reasons why you might want one or the other. Auto detection is kind of cool. Auto detection is a fairly new thing, but it allows you to plug the probes onto a circuit and it can understand whether you want to measure resistance, voltage, current, capacitance, inductance, or whatever else based on the characteristics of what it's actually touching. So the meter can understand to a certain degree what you're connected to, auto range, find the resistance, capacitance, or anything else. We're looking at some from overseas that do this. There are limited ones on the market. There are drawbacks to that as well. Sometimes you want to measure the internal resistance of a capacitor or of an inductor or something else like that. And it goes, yeah, but you're measuring a capacitor, so I'm going to give you the capacitance rather than a resistance. So there are still reasons why you might not want an auto detecting one too. Resistance and continuity is a pretty common thing across most multimeters. Capacitance and diodes less so, but it is available on a whole heap of different ones. If you're doing circuit work or diagnosis, it's really important. Your min-max hold, so if you're measuring a signal that's going up and down, you only really care what the maximum of that is or the minimum, great. And displays. Displays, one of the underrated things, I think. It's the most common thing that you're going to be looking at on your multimeter. So is it bright? Is it large? Is it easy to read? Is it backlit or whatever else comes into it? This has got giant numerals on it, so if you're like me and your eyesight is not the best, having bigger numbers can make it very, very useful to see. Display count is another thing that's a very specific thing. So display count, a way that one of these meters is measured. So let me turn on, say, the Fluke that's here. So this is what's called a 3.5 digit display. So it has 1, 2, 3 full digits and a half digit at the front. And the half digit is designed so that it can't go the full range. It can't go from 0 up to 9. It can only go from 0 to, this is a 4,000 count, I think. So this can go all the way from 0, 1, 2, 3, 4. As soon as you want a 5 at the front, you're going to have to switch the range or use the auto ranging to jump to another range to make that work. So with something like this that's a 2,000 display count, if I was working on a 12 volt circuit, I put it in 20 volt mode and I'm looking at voltages in and around 12 volts. That's fine, that's accurate enough. If I was measuring a 5 volt circuit though, I'd have to still put it in the 20 volt mode to be able to see the 5 volts that I'm looking for. And if I'm looking at little variations, it might not be accurate enough for what I'm really trying to measure because I haven't got enough room on the display for all the accuracy that I need. So going to a 4,000 count or a 6,000 count might give me more details. Remote head, multi-line and graphing are more for industrial guys and doing multiple measurements at once. Remote head means I put my meter over in the switchboard where it needs to be, and then I take the little display with me back over to the process controller or the computer, and then I can make changes over here and see the results without having to go backwards and forwards or pay for a second person to be on site who's calling stuff out from the switchboard backwards and forwards. They're quite expensive to do. You don't get them on entry-level meters, but they're less expensive than a third-year electrician or even a first-year apprentice to read out, and scream out results across a factory for you. Remote heads are quite good fun, and you can do a lot of that with apps, which is something about your data connection logging later too. This little Bluetooth meter here has an app for it. So I can put this into my circuit, do something, and then view it via my phone 10 meters, 15 meters away if I want to. This has got a tiny little display on it. It's backlit, which is nice, but it is still quite small. On my phone, I've got a nice big 6-inch display, and it can graph the line and the trend over time and all that other stuff like that with the app, which you can't do directly on the meter itself. So adds to the use of it without adding too much to the value as well. Value, cost rather. True RMS I'm going to get into on the next slide after this one. Fused or non-fused, obviously if you plug a normal meter into an automotive circuit and it's pushing 60 amps, you're going to blow out the meter. And if it's got a fuse, great, you might be able to recover it and put a new fuse back in. If it doesn't, multimeter in the bin, go and buy another one, which the people at Radio Parts will thank you for. And if you could keep doing that all day, every day, you'll keep the lights on and everything going. But I think if you're doing that, you might want to examine your head as well. It's quite an expensive way to do some testing. Grabbing a fused one, understanding what you're doing, choosing a meter that matches what you want. Don't do automotive stuff unless you've got an automotive meter, or understand where you're plugging in and testing so that you don't kill your meter all the time. Last couple of things, data connections and logging. So there are some that have optical or RS-232 connections, other ones that do wireless connections. That can be quite useful depending on what you need. Logging on the unit, so you can put it in a cupboard, leave it there, understand what the power does over a day, 3 days, over a week or so, and you can see where the spikes are coming through, and you work out, oh, that's the pool pump that's coming in that's knocking out the Wi-Fi, or that's the heater switching on at night that causes a drop in voltage that means that the fridge switches off and then it has to recycle itself back on again. And the last thing is physical. IP ratings, robustness, the size of them, and mining applications and things like that. So the biggest meter I have here is this beastie. This is an IP65 rated multimeter. So I could be standing outside in a rainstorm doing measurements with this one and the meter's going to survive. If I'm doing high voltage or high current measurements outside in a rainstorm, I've got more worries about my survivability than the meter, but at least if I drop it in a bucket, it'll still survive and come out the other side. Heavy duty, rubberized case, this will take some knocks and keep on swinging as well. So compare that with, let's say, the cheapest of these ones. And you've still got a rubberized coating, but a lot more hard plastics involved. Drop that onto our polished concrete floor a couple of times and it probably won't be doing quite the same job it did before. And if anybody drops my precious analog meter on the floor, then they're going to owe me another 50-year-old multimeter. But come up and play with it later. And there are mining rated ones, there are explosive rated ones, there are multimeters for your purpose. Looking at these ones for AC/DC voltage and current capability, these three are almost identical if you look through most of their specs. The ones that I'll spot here, these two both have microamp ranges on them, so for really tiny little current measurements. Again, probably circuit work more than anything else. This one's only down to the milliamp range, but it will actually take up to 20 amps for 30 seconds. So it's designed and tested for that purpose. This is a 115, I think, from Fluke. So if you are that automotive guy and you weren't paying attention, put it on the wrong part, it'll take it for a little while for you to go, ooh, that's over range, ooh, disconnect, and it'll survive. Do the same thing with a normal fused meter and the fuse will burn out and you'll have to replace it. And fuses in these things can be quite expensive. Between these 3 meters, you've got one average responding, which is the little Uni-T one, and you've got 2 true RMS ones. Now, true RMS is something that you want to make sure you get right and understand. True RMS is all about how it deals with AC current and AC voltage. Nothing to do with DC. Doesn't make DC more accurate or less accurate, doesn't matter. If all you ever do is DC, buy the cheapest average responding one if that's all you're trying to do. With AC though, an average responding meter takes every AC waveform and treats it as if it's a sine wave. The maths and the whatever's built into the circuitry looks at the signal coming in and says, you're a sine wave, let's measure as if you are one. So if you're dealing with normal sine wave stuff like wall voltage or anything else, it's perfect, it works fine. You don't need anything more than an average responding meter because of that. If you do anything with square waves or anything with an unusual circuit or anything else that's not pure sine wave, you're going to be well out with your non-true RMS meter. Basic square wave, same height, same frequency, everything else like that, you're going to over measure by about 10% or so. You put it onto that little one, your single phase diode rec, and you're 40% under what it's actually producing. And that's not going to help anybody at all. So that's the question to ask. Okay, CAT ratings. CAT ratings are less about the voltage that's on a component. So if you have a look at, say, this will do. This meter has got CAT ratings on the bottom of it, and you can see there what they are. All of the meters that are up here have got different CAT ratings on them. Some have got different CAT ratings depending on which actual outlet or which testing you're actually putting them through. Now, a CAT rating is about where you are doing your testing in relation to the mains voltage from the outside world. And I'll make it simpler, but essentially it comes down to the capability you have of having something go wrong in terms of a voltage spike. Okay, so it's less about what you're measuring within that and more about how isolated you are from something that's really going to hurt you and really going to try and take you out. So category 1 is circuits not connected to main voltage. I don't have anything that's category 1 here. Everything's Cat 2 or above. And the idea with this is if I'm doing work inside an audio amplifier on a benchtop and it's not connected to power, the chances of a voltage spike coming in from mains power is not very good because it's not connected to mains power. If I'm doing work on, inside of a projector or I've pulled a power supply open or something else like that, that's category 1. Category 2 is mains connected stuff. So say your corded drill versus a cordless drill. Cordless drill Cat 1, corded drill Cat 2. UPS, something that's live on a circuit, mains connected, off we go. 3-phase distribution. So your arc welder that's in your shed on 3-phase. Commercial lighting systems might be on 240 volt, but high current 240 volt. Or they might be 3-phase, electrical switchboard work, industrial work, and so on. You're dealing with a different level of protection you need. And Cat 4 is when you're directly connected to utility power. So that's, say, your transformer on the street outside to your house. Fluke are sort of the kings of all of this stuff in terms of education and training. They do it this way, and you can sort of see, they talk about the origin of installation where low voltage connection is made to utility power. They've got pumps, they've got underground lines, wells, all sorts of other things like this, polyphase motors, lighting systems. This, I guess, gives you a bit of an idea of what we're talking about with your isolation from the mains or the outside voltage. Where you're dealing with outlets that are 10 meters away from a category 3 source, like these, or 20 meters away from a category 4 source, like these ones, you're technically in a category 2 area rather than a Cat 3 or a Cat 4. So yeah, it's interesting when you sort of look at it this way and put it together. What it means for your customers though is where these sorts of things come in. So less so about the voltages. You can see all of these are pretty similar. That's a category 2 meter to 600 volt, working voltage 600 volt, category 3 to working voltage. So either of these ones you can work on a 415 volt circuit, for example. They will both work on that circuit. But this would be a 415 volt circuit inside one of these things that I'm working on. This would be a 415 volt circuit that I'm working on that's connected more to the outside power. And through to this one, where I can work on 415 volts at the street level down and into it because my peak impulse transient is a lot higher. So again, for an electrician, they'll need to know these sort of things and make sure it works. But for you guys, if you're talking to a customer or trying to understand what they're doing, just ask them, what sort of work do they do most of the time? Are you only dealing with inside a circuit and a small thing, or are you actually going to test the mains voltage from the street? If you are, then yes, category 4 and above. Well, no, actually category 4 is the top one. Data connections and logging I already went through briefly. Free apps for them all. Fluke has one called the Fluke Connect App. There are a few different devices that have it. If you see FC in the name of the device, that means Fluke Connect, and that will create a connection to your mobile phone and view all the, view what's going on to it remotely. So again, for process control and industrial guys, put that meter over there, then back with your phone next to your computer or next to the process gear that you're actually working on, and you can see what's going on with your circuit. Okay, that leads me on to current clamps, conveniently. So current clamps are designed to measure the current flowing in a circuit without disrupting the circuit. You can run it live. You don't have to break anything to make a current, to measure the current in a circuit. A current clamp, well, they start from quite small and work their way up, but has a little jaw on it like this one. Generally speaking, they've got iron through them. You clamp them around the outside of the cable, and I can measure the current going through that cable from there. Simple as that. I don't have to do anything to it. I can measure it while it's live. I'm not going to hurt myself by doing it. Everything's fine. The problem I've got is the way a current clamp works is it needs to measure the magnetic, well, it's reacting to the magnetic field produced by a cable. When you've got something like this, I've got an active neutral and ground all running through the same cable. I'm cancelling out my magnetic fields from the cable I'm interested in by the other ones that are in there. So to do this kind of measurement, if I do it live, as it were, put this into 2 amp mode, put my light on, my thing is on, and I've got no voltage run or no current running through it according to this. So great, I can cut this cable open and start playing with it, right? Nope, please not. This will not work to measure it when I do it this way. So instead, what I've done for testing purposes only is create a dodgy cable. If you see a cable like this one on a building site or at home, or if you're like me and your grandfather used to produce cables like this to play around with, run the other way, he lived a great long life, so he obviously knew what he was doing well enough to be careful with it. But now I have my wiring going like this. It's not on, now it is. Now I take my same meter that I was looking at before. I've got 3 wires in here, my active, my neutral and my ground. If I now clamp this over my brown lead, it's supposed to be in the center, but it gives you an idea. Now I can see that there is actually current flowing through that lead right now. Okay? So for an industrial electrician or something like that one, or if you've got an isolated circuit where you've got wires that are exposed inside, a current clamp is a brilliant thing. A lot of electricians actually build a similar sort of lead to this one for testing purposes. They put a plug at one end, a socket at the other, and have the wires exposed in the middle so they can do this kind of testing while the circuit is still live. Electricians can do that. I don't encourage anybody else to do it, but that's how these things go. And depending on the clamp you've got, you may also be able to measure DC current as well. It's a different type of clamp though. So this one, if I go across to my amperage range, put this through, I've got this into a little DC circuit, put this through here, measuring 0. Take my other cable, still measuring 0. There is DC flowing through this because my little camera behind here is actually working. This doesn't have the right type of jaws, so it can't measure DC current that way. It's got plugs in the bottom though, so I can put it into a circuit and use like a normal multimeter and measure DC current the other way. If I take my big chunky Fluke, which would be a very expensive way of testing this out, I put this into DC current mode, and I think I can turn the screen on. Yes, I can. So I'm now in DC mode. Where's my cable? Put this over my cable. I've got not very much going through it. There we go, that's the one I'm looking for. So this is my camera. If I cover the camera over, so I force it into night mode, you can see my current load goes up. So this is measuring DC current live, as it were. So for people who want to deal with DC circuits, buy a different class of clamp meter, and you can also measure DC current using the same clamp. Benefit of these sort of things is you can measure up to 1,000 amps or more with one of these clamps and don't have to actually plug into a circuit. You don't have to touch anything. You just go up to the big cable hanging out the wall, clamp this over it and do what you need to do. Very, very useful for industrial electricians and the rest. So cool bits of equipment, and we sell a lot of them. That one has got the Fluke Connect built into it as well, so you can still do this. Clamp it over the cable in the cupboard, then switch on your bit of equipment over here and watch what happens to your current loading as you go. There are some current clamps that you can add on to other multimeters as well. So if you bought one of these or these as your primary multimeter, plug in a clamp accessory to it, and then you've got the ability to do those same 1,000 amp or more current measurements. I think the Fluke Connect, that big 374 that's over there, there's a soft coil for that that can take up to, I think it's 6,000 amps worth of current running through it. So yeah, you can go as far as you need to with it. Last little thing on the multimeters side for these, specialized testers that do things better than the normal. You're always dealing with resistance, capacitance and so on. You need a wider range and more accuracy. There are testers that do just that. If you want to measure temperature, you can buy a basic multimeter like this one that comes with a thermocouple and adapter to plug this into here and then measure basic temperature ranges using that multimeter. This is a pretty cheap multimeter. They're about 50 bucks or so retail. And it comes with all that stuff to do a basic temperature test. That's fine for maybe some domestic jobs and simple stuff. The 116 that's here is a HVAC specific multimeter. So it's designed for guys who deal with heating, ventilation and air conditioning systems, and they're dealing with human temperatures, so minus 40 degrees C to about 400 degrees C, depending on what they're trying to do. That's what that meter is capable of. You take a specialized one like this one, and now we've got minus 250 degrees C, all the way up to nearly 1400 degrees centigrade, depending on the thermocouples and adapters and things that you use. So for somebody who's dealing with industrial electronics or a spelter or something else, you may need to have all those extra ones to make it work. In that sort of space, there are also thermal imagers and other things that mean you can stand a long way back from your 1500 degrees C vat of steel or whatever it is, and actually see what's going on without having to get anywhere close to it. So the last one that's here is an insulation continuity tester. This is basically a resistance tester. That's what it is. But it's designed for electricians and industrial guys to measure the insulation rating between two things. So the insulation rating between the copper core and the plastic that runs around the outside, or from the voltage contacts on a motor to the outside of the shielding for that same motor. And there's a whole heap of things you can do with these. They're part of an electrician's stock in trade. They have to do it, they have to use it. If you're worried about performance on cables over time or degradation, an insulation tester is your beast. Okay, these are my own little pet project. I would love every single person that walks out today to have a non-contact voltage tester, an NCV tester. This is all it is in its most basic form. They're called volt sticks, volt finders, a whole heap of other names like that. Their simple operation is I take a cable, I have it into power, and I move my wand near it, and I can see that there is power flowing through this. That includes power points in the wall, the power board that's here. Depending on the sensitivity, you may be able to pick up DC with it as well to show that a circuit's live and active. This could save your life. If you're boring a hole through a wall and you didn't know that your power connection runs along in a particular direction for it, I would drill through there and hit a live voltage, and I hope that my drill is insulated enough to be able to deal with it when I do that. There was an unfortunate case a couple of years ago, I think, of a guy doing work in a roof, and there was insulation that had been scraped off or damaged on a cable, on a 240 volt cable that was up there, went live onto one of the ceiling joists, onto a bit of metal. He put his hand on the metal, died. Got the bad electric shock up in the heat, up in the roof, and couldn't be recovered, looked after in time, and he died. So there's now restrictions on what you can and can't do in roof spaces. There's isolation that you're supposed to be putting onto switchboards and so on to make things work. If he'd had one of these things in his pocket and he just waved them across all the bits of metal that was in the roof before he did it, he'd still be with us today. So having even a cheap one like this with a little torch in it as well, dual purpose thing. It's a torch, great, really useful, but it also might save your life at the same time.
What's its range then?
Ranges are generally pretty short on ones like this. So this is, will be live. On this one, I think I've dropped a few times, so it's slightly damaged. But we're talking about a centimetre or so from it. So if you want to know that this is live, this is great for it. With the Fluke versions of this, costs a lot more, but it has a thing called volt beat built into it, so it does self-testing every 2 seconds and gives you a double flash to show that it's still doing its job and it's doing its job properly. They're more expensive for a reason. Electricians swear by them. They also swear by, where's my 117? So this is what I consider the ideal starting multimeter for an electrician, and it may be used for 20 years or more as for basic jobs. This has a volt alert sensor built into the top of it. So a little light and it will make noise. And it's more sensitive than the other one is. You can pick up from further away. So that live connection, we're about 10 or 15 centimeters away from it. When I was looking at it before, my wall plate is live. I can find where the voltage wire is running through the wall to work out where it breaks contact and where I'd be safe to drill into the wall if I needed to. It's a lot more accurate. The other ones that do it are almost every one of the current clamps, because it's part of how they work, is the same sort of idea that a non-contact voltage tester is. And again, depending on the type of clamp, depends on the accuracy and the range and everything else that you want to do. So yeah, if you are that type of electrician and you've got that sort of gear with you, this one doesn't make noise, but it gives you a nice big flashing light to show you what's going on as well. So look for NCV, non-contact voltage. It's on a lot of meters and testers out there, and it's a very useful thing. As I say, it may save your life. Last one on the electrical testers is about oscilloscopes, because these are one of my favorite things, but I'm a uni lab geek and I love small circuit work and things like that. A multimeter can give you some general ideas about what's going on, but it can't tell you a lot about what's actually being seen in a circuit and how it's working properly. So where's my, this, going back to here. In fact, let's just do an auto search while we can. So an oscilloscope is designed to show you what's going on with a circuit. It has a voltage up and down, or a measurement up and down against time is your horizontal axis that's here. So I'm feeding it a 100 hertz signal. That's a 100,000 hertz signal instead. Whoops, I'm adjusting the wrong one because I'm not paying attention. From here, I can dial in and have a look at my individual parts of the signal. I'm in the microsecond scale range for it now, and I'm in 100,000 hertz. I switch this back over to the traditional one, and I can measure the width of the signal. I can see pulses as they happen. I can see spikes. I can do all that other stuff like that with it. You can have multiple channels. This is a 2-channel version of it. For anybody who does circuit work, that's an essential part of your tools, an essential part of your equipment. One of these on your benchtop will show you exactly what happens with a signal. If I am on that 100 hertz signal that I am there, I'm on a square wave. If I dial into this and up the scale a little bit, you can see it's not much of a square wave. You can see that it tails off as it comes up to here to get up to level, and then it drops away at the end of that cycle to see what's going on for it. That's because it's a cheap little, signal generator. It's not really doing much else than this. And for basic uses, that's absolutely fine. If I had that response in my circuit and I was expecting a nice crisp part, then I'd be looking at my components in the circuit and saying, I've done something wrong, or the circuits aren't performing the way they're supposed to. How do I fix this? And that will show you how all that works. When you're looking at little transient responses, little things that happen over very short periods of time, an oscilloscope will see them in a way that most meters won't. There is a rule on here called the 5 times rule for bandwidth. So one of the most common things you'll see on these is the bandwidth measurement on the top. This is about how it will represent a signal that you put onto a screen. So say this one that's here, this is I think a 10 megahertz signal. If I had a 10 megahertz bandwidth, I'm going to see distortions based on the way this is measuring. If I have a 200 megahertz bandwidth, I'm actually getting my proper square wave that's coming through it. So buy the biggest bandwidth that you can, or choose one appropriately based on the circuits and the testing that you want to run with. And the 5 times rule is based on frequency, what am I looking for? Frequency, doubling, quadrupling, fundamental frequencies and so on for it. So useful to know. Troubleshooting and debugging and all that sort of stuff, an oscilloscope is your best friend. A lot of the modern ones have now got USBs, got storage on board, and a whole heap of other things for it as well. Okay, Moving on to more general testers, I have 3 levels of testers. Verification or continuity testers, a qualification tester, and then a certification tester. So verification is it connected? It'll tell me about the copper or whatever, that's it. Does it actually, the wire's in the right order, is the copper connected? That's all a verification tester does. A qualification tester takes it to the next level and says, how well does this do the job that I've told it to do? Will it do what I need it to do? And the certification side is somebody's looking over my shoulder, somebody's going to audit me, I need to produce documentation that says it will do exactly what I say it does. It's not what you use for your own home, but it's what you might use if you're wiring Parliament House, for example. So, in a tracer sense, these are tracer and continuity testers and verification testers. They're all just going to look at copper. So take the LCT8, which is I think I left in the box over there, or a basic tester like this one. All this is really designed to do is to measure whether copper is connected to copper. So I take a good cable, I plug it in, and I put it into test mode. And you can see that little LEDs run down the thing, and it says, number 1, number 2, number 3, number 4, number 5, number 6, and so on. And my shields are all connected, and hey, look, copper is connected to copper. Great. That doesn't tell me how good that cable is, it just tells me that copper is connected to copper. And it can get it wrong if there's a temporary problem or a slight disconnection problem. So I broke this cable. Found this random bit of stuff lying around at home, and I bent it backwards and forwards about 20 times. And now I do my test on it. That looks all right. It's doing its job, right? This is cable, it's fine. I can plug it in. But then why isn't my PC working? Why can't I talk to the network? This test is not telling me that. If I start playing around with this a little bit more, I might get to a more broken condition, and then you might see that some of the pins drop out. But it's pretty resilient, it's kind of okay, but this isn't telling me what's the whole story about what's happened to it. Visually, I can look at this thing and go, that really shouldn't look like that, and that's been really nasty. If I take a qualification tester, like this one, now I plug this in, and I'm going to do a test on it. And it's passed. Great. Fantastic. As the pin outs go, it's passed. If I look at it again, no worries at all. No splits, nothing else is going on for this cable. If I now plug this into this meter to an active switch and do the same tests, it's going to start going, it's only capable of 10 megabits because only 2 of the wires are connected at the speed and the quality that it actually needs to be. And if I keep doing this sort of split test for it and playing with the cable, I end up with different results depending on exactly the configuration it's in or everything else that's going on to it. So the NP800, this kit, is one of my favorite tools that we have. Not just because it's a great tester for data cables, but because it's actually an active network cable tester as well. So if I plug this into a modem or into a PoE switch, I can measure PoE conditions, I can get an IP address from a network, I can look at DHCP through it, make sure all that sort of stuff is working. So if you are working with data cables and data networks, this is an invaluable tool to have. It comes with a whole heap of remote IDs like that one, so if you're not sure which cable is connected to which after you went through or somebody didn't label all the cables properly, plug this thing in, use your IDs to work out what it is, and then go from there. These little ones are IDs for wall points. So I plug this into a wall point here and then plug that into my rack upstairs, and I can work out which cable goes to where from my rack end. So, what are they, 20 of these little testers that come with it? And it has coax testers in the box too. So if you're also doing antenna RF work, this will give you all that sort of ID and information too, all in the one kit. This is a qualification tester. It will not certify that a cable does exactly what you want it to do. That's where things like these come in. And Fluke's Versiv, DSXs, micro scanners, link runners, and so on, depending on which one is which. This will give you printouts, will give you reports, will test all the way up to category 8 capability. It'll test fiber connections depending on the accessories and other things you choose for your $15,000 plus price tag that goes with it. If you have $30,000 to do this, and if you do certification once a year, great, I've got some really dodgy alpaca investments I want to interest you in, because you've obviously got too much money to spare. These sort of systems are designed for certification in government buildings, mine sites, some corporate offices, Australia Post offices and things like that, where they need to know that exactly what's going to happen, because they're spending public money or they're spending shareholders' money, and they want to be sure they get the best value for money. Oftentimes these will be, there might only be 20 of these in Australia at any one time, and a lot of them will be held by companies who hire them out for a day for $1,000 a day or more, depending on the type of job that you're doing and the number of connections and reporting and everything else that you want to do. So, really, really cool. If you want to buy 10, come and speak to us afterwards. We're happy to help. The last little one on this one is actually another little qualification tester that is one of my favorites. This is for PoE power. So if you're dealing with wireless access points, cameras, VoIP, phones and similar, having this little tool in your bag is going to be an essential thing. So when I don't break it. This is basically a powered device simulator. So this acts as if it's a wireless access point or a camera or something similar. It says, hey, PoE switch, give me a load. I'm going to do something here. You also get the little tester. It's in the middle of it. It's upside down, but you can't read it anyway, so it doesn't really matter. It's got a little OLED screen on it. It's nice and bright to see what's going on. I've got it currently plugged into one of the Ubiquiti passive 24 volt power supplies, and it's showing me that it's pulling 23 volts at 0.13 amps or 3 watts is coming through to power up my little wireless access point. If I plug this into the PoE switch that's here, this is a proper PoE switch, so you get a nice 48 to 54 volt signal. It'll tell me the load. If I'm plugged into my camera, it'll show all of those sort of details for you. Even without a load into it, like the access point that's there, if I'm plugged into a 24 volt supply, my light goes green here. If I'm plugged into, and if I do this and grab spare cable, plug into here and into a normal PoE supply, my light flashes. So green flashes show me I'm into a normal PoE circuit. Green solid shows me another one. At the moment I haven't got a load plugged into this one. If I plug my camera in, oops, got this around the wrong way. Yes, I do. Plug into here, and then I'll be able to see what my camera actually pulls in terms of voltage and current. So if I'm dealing with CCTV camera install, I've run the cables. If my camera's not performing properly, I can plug in this instead of my camera and see if I'm getting the voltage and current I need to make it run. If all of that's right, I can plug this in and make sure that my source is doing what it's supposed to do, or that my camera isn't pulling an abnormal load for some reason. If you're doing the same with wireless access points, it doesn't matter whether it's passive or active or anything else along the way, it will still work for you. This little PoE-Z is a brilliant little beast, and unpowered. No batteries, no charging, no nothing. It's always ready to go because it's pulling the power from the devices that are in the network itself. That makes it invaluable. The other thing I really like about this one is it's capable all the way up to the new standards, which are PoE 802.3 BT Type 3 and Type 4. 802.3 BT Type 4 is up to 100 watts of power over a data cable. So this will cope with potentially an LCD TV that's powered via PoE, which they exist. They're test cases, but you could run an entire TV off a single PoE cable rather than having to have extra power supplies and other things. Run all your signal, run all your video information, run everything else like that over a single data cable. And this little tester will actually do that job for you. I've got crossover adapters. You can see how all this sort of stuff works if you want to come up and play with it afterwards as well. All right, so data cable testers, we looked at qualification and certification testers for those. My last little one of this lot is HDMI. So we deal with HDMI all day, every day. We sell tens of thousands of cables every year, ranging from super skinny to super long, some with optical, some with just straight copper, and everything else in between. Different brands and everything else to do with it. HDMI splitters, audio extractors, HDMI over CAT adapters, and everything else that goes with it. In the latest catalogue, the latest newsletter, you'll see there's about a $30,000 switcher with HDMI inputs and outputs and control and all these other things like that for it. Now, how do you know that the HDMI is performing when that happens? If I bought one of these testers for about 50 bucks, all it's going to tell me is that copper is connected to copper. So if I take one of my test leads that's here, and what you should see, because this is one I have specially prepared earlier, when I ran my test for this one, you can see that there's some missing LEDs there. That's because this is an old damaged cable from one of our customers, and I think you might be able to see there's light coming through the end of one of these cables where a Stanley knife went through it. So it's missing a couple of bits of copper, so it's not testing out properly. If I plug this same one into this 10-meter cable that's here and do essentially the same test, that one, that all looks good. Everything's connected, everything's in there for it. Now, who can tell me whether this is a 4K 18 gig per second capable lead from this test? No idea. This doesn't give me anything other than the copper's connected to copper. So my cable is good for a given value of good. That's fine. As a basic test, just to show that the lead's not damaged or dead, this is a really useful little thing. And you should be testing cables out with something like this one, even in a domestic and basic setting. If you're running a cable through a wall, a little 5-meter cable or 3-meter or something similar, plug it into this and go, oh, copper's connected to copper, we're all good. And I've used this before to find where a cable was run through a wall, it was damaged after installation because the plasterers went through and crammed it in together and the cable started to fail and cause problems. So a simple test is enough for that kind of job. However, if I want to actually qualify what that HDMI lead's capable of, I need to jump to these instead. Now, those of you who have known me for a while will know this is about my favourite product that we sell. It's the Murideo Fox and Hound HDMI test kit. You get 2 boxes with it. One's a generator and one's an analyzer. The generator that's here can produce any kind of HDMI format all the way up to 4K 18 gig per second. Different resolutions, different frame rates, different colour bit depths, different audio combined with it, HDR and all sorts of other stuff. So you can create almost any source that's out there with one of these. So if you have a Foxtel IQ4, you can pretend as if this is a Foxtel IQ4 even before you get your box delivered to you in the mail. So if you're an installer doing a system for somebody and you put all the cables in 6 months before the rest of the hardware arrives, you can be sure that you're generating the same signal as everything else that you're playing with. For corporate installers where you're doing a laptop to a projector, is that laptop going to be old school VGA, 640 by 480, 4:3 resolution, or is it going to be an Apple with a USB-C to whatever adapter running 4K running out of it? You can pretend that this is any of those things that you might want to throw at it. Really, really, really useful thing to have as a starting point. The other end of it is the analyzer. So I can run this through the system, plug this into every point in my distribution, make sure that the same thing's coming out the other end that was being put in at the first place. So if I run around all the house and test every TV point for this, it says, great, everything's going through properly, then I can walk away from the job and know that it's going to work. If something's going wrong, this also lets me see what the signal is. And I can look at it and say, oh, HDCP is not syncing properly. I need to do something about that. Or the audio is not coming through, the audio is not going through the splitter. I need to look at the splitter and look at the settings for the EDID to make sure that this works properly and so on. This will show you what condition the signal is in by the time it gets to the other end. You can also use this to do a cable test all the way up to 18 gig per second. So I can plug in my let's say this little white lead, plug it into HDMI here, and HDMI here. Okay, power. And you won't be able to see this properly, but I'll hand it around so you can have a look for yourselves. Okay. Let me see. There we go. Signal's coming through. This is a 4K capable lead, or it should be. And black screen on this side, so black screen on this side. If I'm trying to remember how I changed the images on here. I think it's side to side, yeah. So there's a 1080p 60 Hz signal that's going through, and I'll get my test pattern coming up in a second to show me exactly what's going on with it. From this end, I can do a cable test, and I can do it all the way up to 18 gig per second. So I do that. And now what it will do is it'll run through a few tests. It takes about 10 to 15 seconds. And it'll test whether 5 volts there, whether data clocks are correct, and whether it passes or fails. The 18 gig per second test that I've run through.
Yep, no errors.
So it's passed 0 errors for everything, and it's passed my 4K test. Great, no problem. Let's try it now with this one. So this is our 10 meter cable. So we'll just plug it in the same way as we did with the other ones. All right, this is a heavy cable, so you might have to hang on to this one in a second. Got that one there, and this one here. So I now do that same cable test again. So I get my 5 volt lead, so it's got the hot plug, it's, does 5 volt properly from end to end. What are my data rates, and what is the rest of my signal going to say? Well, still working on it. And it's given us a pass. So this cable is 4K 18 gig per second capable, this specific one. However, this is not a cable that's been certified by the factory with their $40,000 testers as being 4K 18 gig per second capable. What that means is you may get individual ones that are, but it'll depend a lot more on the variability of the manufacturing or on the conditions or whether it's bent slightly or how perfect the copper is on the end or the gold is on the end of the connections for it. So if you have a cable already, this will tell you whether you can use it without having to replace it through the wall. So if you've done a $50,000 install for a customer 5 years ago when 4K was barely a glint in the father's eye, now they want 4K Foxtel running through. You can run this test using this equipment and say, hey, that cable I put in there, I spent good money on that cable, it's still going to work for us, let's use it and run with it. If you don't have that, all you can do is look at the specs on the cable and say, it doesn't say 18 gig, I'm going to have to charge you $500 to run a new cable through the wall to make this work. Okay, so this sort of meter can actually save you a lot of money, can save you a lot of hassles too. Really, really important tool to have for anybody who does audio-visual work, or actually you can run through any of the other tests, the generator from there, and then it'll come out on the other end for you. Anybody who does antenna work, I would love them to have one of these things. Electricians who do audio-visual work, I would love them to have one of these things. If you are an audio-visual integrator and specialist, you need to have one of these things with you. It's just going to save you so much hassle and so much time. Okay, so that is a qualification tester for HDMI. Certification testers tend to be in the factory, and they will be $40,000, $100,000 or more, and they do a lot of extra testing on top of these ones. And they give us the certifications that we can print out and give to you if you need them to show exactly what the cables are capable of. All right, but as an everyday tool, the qualification tester is kind of your beast. Up on the table here, I have a couple of others that I didn't talk about, namely PowerPoint phase detector, and I've got this little redback 100 volt line speaker tester. For any of our guys that anyway have a customer has an issue with these things, invoice them out for it on their 30-day account. Make sure that they take this to site, test it out, do whatever else is going on for it. It's something we've done for years. We get maybe 1 in 10 returned after that point because they love them, they find them so useful, they just pay for them and keep them. So we don't mind that at all when that happens.
So mainly impedance.
Exactly. So you've got, say, all the speakers in our showroom here. How many speakers have we got? Are they 8 ohm? How are they wired? Are they low impedance, high impedance, whatever else is going on? If you're us, we know, we put them in, we know what the speakers are and we know what they're going to be, but do we know what they're tapped at? 15 watts or 3 watts up there. If I've got to replace that amplifier, do I really have to get up and pull down 500 speakers to look at each one and go, yep, 3 watts, yep, 3 watts, yep. Or do I plug this into the line and it gives me a total loading and says, you've got 120 watts worth of speakers on that line. And it does that in 5 seconds. That's the simplest way to do it, and they're really cheap compared to what you actually get going on for that. Question I often get with these impedance meters is, well, it's just impedance, it's just resistance, right? So I can use a multimeter to do that same test. Is that true or is that not true? Not true, definitely. Tim has a big rueful grin on his face. He gets that question all the time as well. Well, when you're dealing with an audio signal is an AC signal, not a DC signal. We say 100 volt, but it's 100 volt that moves up and down. And there's transformers at each end. When you try and do a test of an impedance across a transformer, DC resistance very different from AC resistance across a transformer. So what they do with a meter like this one is they produce a 1 kilohertz test tone throughout the whole thing and measure the AC resistance response to it. And that gives you a roughly accurate wattage for it, within maybe 5 or 10%, which is more than enough to do what we're trying to do with all these things. So anybody, again, who deals with commercial audio needs to have one of these things in their test gear, okay? Beautiful. All right. Last thing then. Everybody loves freebies, so I've got some stuff to give away. John, you are ineligible because you turned up too late to the training session. Yeah. It's because John knows everything already. So I've got these 3. There's a clinical thermometer, a basic tester with auto ranging, and one of my favourite volt sticks to keep you alive. So you get to choose which one of these based on who, when you get the answer right. It'll be just a basic hands up type of response. Don't call it out, please. All right. My first question. My favourite testers, the ones that might save your life, are known by NCV testers. What does NCV stand for? Yes, Ken? Non-contact voltage. Perfect. Fantastic. Thank you very much, Ken. Would you like a multimeter, a voltage finder, or a thermometer? One of the sticks? Beautiful. Excellent. There we go. Thank you very much, Ken. All right, I've got two more to give away. Let me see. What am I going to ask about? Okay. Talking clamp meters. If I use a clamp meter on a cable like this one to measure AC current, will I get an accurate measurement? Yes or no? Hands up. Oh, I think Mikey was just fastest on that one. You will not get an accurate one. That is because?
It's measuring insulation and it's measuring magnetic field as well.
Yeah, you're measuring multiple cables in the one sheath and they're stopping each other working against the other. Isolate your active, your neutrals and so on and it will work. Mikey, would you like a thermometer to measure Amara's temperature or would you like a little thermometer? Beautiful. Thank you, Mikey. Pleasure. All right, I have one last one. And this is talking about our Fox and Hound tester, the HDMI tester that's there. I have 3 terms for testers: verification, qualification, and certification. What is the Fox and Hound? Yeah, you got in first, Daniel.
It's verification.
Yep.
You're seeing it come through.
Yep. Verification, yes, but it's also a qualification. It's a qualification one too. Yeah, not certifier, but it is verification and qualification. Difference between them is verification says the copper is connected to the copper. It does that test. qualification says it also does these things up to a certain point, but doesn't print out a report, so it's not a certifier. Beautiful. Then a multimeter is yours. Thank you, Daniel. All the rest of these gear, if you want to come up and have a play with it, if there's something specific you want to ask me, come and find me afterwards. Otherwise, thank you very much for your time. I appreciate it.